Okay. So. Okay.
What about the couple tornado in this bitch?
Hey, Wig.
Yeah.
Do you have a pen?
You got an air filter?
Yes.
I got a pencil.
I do.
What's wrong with your pencil? She's being extra. I'm sorry, you're going to have to use your pencil.
Yo, I have that.
Okay. So, do you remember back in Math 1 when you did next, now equations?
Yeah.
I remember MS plus B.
Okay,
That's all for thing.
that's okay, because that's what I need you to remember. All right, so first off, this entire chapter is on sequence and series. Lucky for you, all we have to do in chapter 9 is 9.1. Okay.
That's all.
But if you notice your note packet, it's a little thick.
Yeah.
That's because your note packet is 9.1, 10.1, and 10.2. Then we're going to test. Then we're going to do 10.3 because it's 4 parts. And then we're going to test. So, because we only do one section of chapter 9, we're only looking at the first section.
But it's just gonna be this week, no?
I heard you say no sleep. Do you have to come for the IXL training today? Let's do it. I mean, I don't have to go to the staff meeting. Then I'm gonna fall asleep.
She said she got secret skittles.
Yeah, she got secret Skittles. You better forget them.
You wanna talk about this? This
Right,
is why we talk about this on YouTube.
Right, get on now.
Because we live.
You're gonna let the world
Will
know.
YouTube people please comment below and let Miss Smith know that candy's not okay?
Period.
She's gonna die. Right, you're supposed to be on a diet. If you don't do your diet, you're gonna have possibility of dying.
2 days.
In 2
All right.
days.
So, in this chapter, we're looking at an ordered list of numbers. That is all the sequences. I've taken some numbers and I put them in order. There's a sequence. Yay, me! So, terms. The terms of the numbers are the values in the sequence. And terms are identified by their location. So, if you take a look at number 1, 13 is A sub 1. It's the first term in your sequence. The projector is overheated. Please clean the filters.
That is sad.
Look, we killing the projector again because it's too hot in here.
Really?
Yeah, you heard of
No, I
this?
did. It said
Huh?
that.
No.
I'll be zooming through it.
He be unscrewing the thing
You don't.
and then flipping the switch.
Okay, so 15 then is A sub 2, 17 is A sub 3, 19 is A sub 4, 21 is A sub 5. And my board's already off. Check that one out. Okay. So, A just tells me that we're in sequence A. I could have called this T sub 1, T sub 2, T sub 3. You can name a sequence anything you want. Okay? Question so far?
No.
Okay. Every sequence has a pattern to it. Can you find the pattern in sequence 1?
2.
It went away. 2 plus 2. So, every time to go from A sub 1 to A sub 2 to A sub 3, we're adding 2. Okay? Okay, so in Math 1, you all learned something called next now, which it means to get my next number, I take my now number and I do something to it. In this case, I add 2.
Yeah, I remember that.
So this means I take 21, which is my now number, and add 2. 21 plus 2 is 23. So the next number in my sequence is 23. My new now number is 23. So 23 plus 2 gives me 25.
That's insane.
Okay? So that's what you learned in Math 1.
Really?
or should have learned in Math 1. Let me rephrase that. This is what you should have learned in Math 1.
Oh, okay.
Algebra is actually.
Oh, I knew this.
All right, so let's look at number 2. What's my pattern in number 2?
You're going down.
Careful, 2's over here. Times 3. My pattern is to multiply by 3. So my next number is my now number
Multiply by 3.
times 3. Or you could write that as 3 times now. Okay, that's the same thing. 3 times now.
I like this.
I don't.
I love it.
Why not?
This is,
When you
these
already
next couple of
understand,
chapters are gonna probably be Alicia's jam.
Jam?
Because we're back into numbers and
Well,
that's what
they're mine,
Alicia enjoys.
So I could take a nap.
No.
What did you get? You can take a nap.
Right. Number 3.
I don't like this.
What's my pattern in number 3?
Subtract 8.
Subtract 8. So that means next equals now minus
Can I
8.
just do n equal n minus 8?
No, we're actually going to change it though. We're no longer going to do next now. We are going to change it. And this is where people are like, holy crap, where did you just get that from? Ow.
I did that.
Ow.
What? What is ow? Is that
Ow.
Because it's going to make your brain hurt.
-29.
Okay. What about number 4?
Algorithm.
Oh, you're
Because
gonna
number 4 is not easy.
Easy.
Out. No,
You go.
minus 2 plus
That's a lot.
7.
7 minus 9 plus 2.
Yeah.
Square root of 7. Well, that's it's next equals now.
Look,
and
it's
then
too hot to think so much. Okay.
yeah.
Can I please just give you an answer?
It's too hot to think.
I like that.
Just please.
What you looking for? Answer.
It's -2, ain't it? Or minus? I think.
What?
No, it's not. Never mind.
I'm curious.
What coyote?
Next equals now.
She look like she wants something illegal.
You got the getting the heroin out.
Would it be? Can the pattern be more than like one number? Can it be like an X and then not an X, a plus a number and then minus a number?
Plus a number minus a number.
Yeah.
Plus W.
Like,
WWE Monday Night Raw.
okay, that's not what I meant.
Okay,
It's 2.
so there is a pattern to this one. Your pattern is to get this number, I need to go back and take this number
Oh,
and I need to subtract this number.
No.
too much.
So -3 minus -5 is a +2.
That's-
Remember, minus a negative becomes plus
Oh, yeah, I
a
know
positive.
I don't remember.
-5
Negative.
minus 2 is -7. 2 minus -7 is 9.
You know why this is confusing? Because later in math 2 and math 3, they'd be like, 2 negatives can't make a positive. They have to stay negative.
Right.
Like, it's confusing. Like, why switch it up on us every single year? This is stupid. Why can't you just keep it one simple thing?
He hated about that one.
Yes.
He's
ain't wrong,
passionate. He's passionate.
You were saying something about where did you get what?
Who you talking
I swear you were back there saying, where did you get this?
Me?
Are you good? Yes.
Oh.
See, okay,
Which
I'm not
one?
nuts.
Which one?
You were looking at this when I was putting in, and you said something about where did she get? Oh, okay. So that means to get my next number, it's -7 minus 9, which is -16.
Whoa.
Because I thought 9
And then
was a
it'd be
positive
negative
number,
16
but apparently
minus
it's not a positive
9.
number.
So it'd be 9 minus -16.
Wait.
Why? Oh yeah.
So I go back 2 steps, use that number, subtract
Yeah.
one step back to get my next one.
Oh, I see. I see what I got confused at. What I asked the question.
You can hit the fans now, can't you?
Huh?
You can hit the fans now?
No, we gotta have the fans play.
Let it cool off a little bit
Yes,
first.
ma'am, I'm sorry, I apologize. I didn't mean to be rude.
Oh my goodness.
I'm sorry.
I understand.
Be a little
why.
being extra right now. All right.
So then-
How are we so far?
Well, I don't like y'all. I don't like them before, bro.
Beautiful thing is, number 4 is not what we need to focus on.
Hey, that's good.
We're gonna need to focus on 1, 2, and 3.
Well, one of those gonna be on the test, right?
Right, a number 4 gonna be on the test and she's like,
What was that again?
you know we gonna get. Got you.
Is that like my witch voice? All right, so your next equals now plus something, or your next equals something times now is what we call a recursive sequence. Okay, so recursive means that we work backwards. So the numbers in our sequence are based on using previous terms. Okay, I need to know what comes before I can find out what comes next. I need the now before I find the next. So we can write an equation, and that's what you did with the next equals now. That's called your recursive rule. This is an equation statement for the pattern of the sequence. And every term or every sequence has what we call a seed. Okay? Your seed then is the starting terms. Of the recursive sequence
Is that an 8?
that are needed to begin the pattern. Okay? Just like every plant has to start with a seed. Okay? Every sequence has to start with a seed. And from that seed, it will grow. You can't English? He says, I can't English.
No, it's English.
English? All right. So this is where everybody starts to get confused because I'm throwing out all these new notations.
Really?
I like it.
No. No.
So
No.
My bad, I forgot.
we've got a sequence. 3, 5, 7, 9, something. Okay, so Alicia knows that this is 11.
Plus,
Okay, so any term that they want me to find is A sub n. Okay, so they want me to find this 5th term. So this is technically A sub 5. Okay, it's the 5th number.
the end is.
If you count, okay, this is A sub 1, this is A sub 2, this is A sub 3, this is A sub 4,
Question.
so this would be A sub 5.
Player 1, player 2, player 3.
You can use P. We can make it P. We don't have to use A.
That means it keeps it simple.
Yeah.
That's fine. You want to use P then?
Yes.
All right, I'm okay.
That was a waste of time.
It's just a matter of you can use any variable that you want. So you said P sub 1, P sub 2, P sub 3, P sub 4.
Piece of pie.
So this is P sub 5.
Piece of pie.
Okay, so A sub n or P sub n, I don't care if you want to call it P sub n. P sub n is the term value at a specific location. So, if I say, what is P sub 4, you should tell me 9. That's the value in the 4th place of my sequence. So A is just a variable that they use to name the sequence. So again, it doesn't matter if I use P. I could use M for Malik. I could use J for Josue,
Definitely not.
okay? Most people stay away from S because it looks too much like a 5 sometimes, okay? But I can use anything I want. N is the subscript. So this is the term location. Where am I looking? Am I looking in the 5th spot? Am I looking in the 27th spot? Where am I looking? That tells me where.
What did it say? Variable?
Yes, that's a variable. All right, so, whew, see if we can do this. I get nervous with this every year because for some reason, no matter what I do with this, it just goes
What, like, over your head or my head?
over y'all's head.
Ooh, my battery power is using all of it.
What?
I don't understand why she just said
All I got was my battery power.
Yeah.
You said all of it.
All right, so let's write this equation as a next equals now. So my next number equals now, and what am I doing with the now to move forward? What's my pattern?
+2.
Plus 2.
That's what goes over people's heads?
No.
Oh.
Instead of doing this though, now we're gonna change it to these.
Where'd you get those?
Oh, man.
Okay. So I'm looking for P sub 5. So P sub 5 equals, well, to get P sub 5, I need
Maybe 11.
P sub 4.
Yeah, this is easy.
And I need to add 2.
Oh, you can't just put 11?
So, in other words, I need to go backwards by 1 and add 2.
Yeah.
So, I would technically write this as P sub n minus 1 plus 2.
That's complicated for like how easy that is.
That's the thing though.
Yes,
So
extra.
it's not good just to find 11. We gotta do all of it.
So, your rule is we're trying to create the equation, not just give me that next number.
Oh.
You need to find the equation that you would use to continuously do this over and over again.
So
Okay, so I could have,
A pizza pie.
let me break this down a little bit more over here. All right, so if I told you that your equation is y equals x plus 2, and I told you that x equals 9, what would you do?
+9.
You would have plugged in 9,
There you go.
added 2,
I got 11.
and got 11.
Yep.
But the problem is when I want to find the next number after that, how do I tell it that instead of plugging in 9 here,
Change x.
I need to plug in 11?
But x equals 11, not 9.
So I would have to change this to x equals 11 and then plug in 11, add 2, that gives me 13. Change this to x
There you
equals
go.
13. Okay, they don't want to continue to change what your x value is. So the way that they do that now is instead of putting x, they're going to put p sub n minus 1. So what this does, actually, let me get back on the whiteboard. That way anybody that needs to watch this later can see it because you can't see the whiteboard from here. Come in. Oh, I have the marker off. That would be why it's not working. No? Actually, that's not gonna help me any.
Well, that fan is starting to feel good.
Is it?
Not to Rodrigo, but me. It's not fine.
Really? There we go. Okay, so let's come up with the new one. Let's do
3,
1, 3, 9,
5,
27.
66.
Okay,
Times
So-
3, times 3. 27 times
my pattern here is times 3.
Do we write this?
You can, if you have room.
It's an example.
So your pattern is times 3. They want us to find this number. So to find this number, that's P sub 5. That's what I'm trying to find. P sub 5. I need to go backwards. One space.
P sub 4 times 3.
Okay, so I need to go backwards one space. So P sub n minus 1, that tells me go backwards
Yeah.
one space. And then multiply by 3.
Is that it?
That's it.
I like that.
So you went backwards 1, so that tells me to plug in 27 here, multiply by 3, and that gives me what?
81.
So this is 81. So now to move on to this number, I need to go backwards by 1 and multiply by 3. So instead of 27, this is now 81 times 3, 243.
So you would put P sub.
And then 240, and this would be P sub 6.
equals P n.
Because you have to go to P sub 5 and multiply by 3. To
Okay.
get P sub 7, I need to go to P sub 6 and multiply by 3. So if you take a look, this is 5. If I plugged in 5 here, what's 5 minus 4? Or 5 minus 1?
4.
4. So this is the value of P sub 4 times 3. If I plug in 6 here, 6 minus 1 is 5. So I took the value of P sub 5 times 3. Okay, and move forward. I'm over it. I refuse to help anyone that has decided that my class is sleep time. Josue, this is your only warning. I have no time for it. Not when we're getting into the hard stuff now. Okay, so does that make sense?
Yeah.
Okay, so if I was given something like, let me see if I can do this without messing it up.
1, 5, 10.
1, 2,
4.
5.
8. How about that?
Actually I lied.
Yeah, but it's
Right.
1, 2, let's do 1, 2, 3, 5, 8.
Yeah, what? Plus 2. Plus 1. No. Wait, is it the thing?
So it's the same type of thing that we did for that number 4.
It's just
Alright, so you got
So
9.
1 plus 2 is 3. 2 plus 3 is 5.
So Derek just said 1 plus 2 equals 3.
3 plus
2
5.
plus 3 is 5.
Yeah.
3 plus 5 is 8. So to get this, I would take 5 plus 8. So to get this number, to get B sub n, I have to go backwards and use this number. Well, how many spaces back is this number? 2. So I call that B sub n minus 2.
Okay.
And what do I do with that? I add it to this number. This number is 1 space back, so I add it to B sub n minus 1.
Okay. Yes.
Okay, so all this n minus 2 and the n minus 1 tells you is how many spaces do you have to work backwards and use that number to move forward. Does that make sense?
Yeah.
Okay, so that's your new now. How far do I need to go back? So if I needed to go 7 spaces back, it's B sub n minus 7. No, you will never have to go 7 spaces back.
Good.
The farthest you're going to have to go is 2.
Oh, really?
that's 13.
This is actually, if I would put this here, this is actually called the Fibonacci sequence.
No.
I heard that before.
Yeah, I've heard that.
You've heard of Fibonacci?
No.
Why have I heard that?
Fibonacci is the natural spiral in nature. So like if you look at a snail, at the shell,
Yeah.
how it builds, that's a Fibonacci sequence. If you look at the petals on a flower and how they bloom out, that's a Fibonacci sequence. This is found all over nature. It is the
Whoa.
most amazing sequence ever.
Don't believe it.
Don't care.
I did a big, huge project on this the one year.
What, just those specific numbers? Is that what you're talking about?
They had to create a Fibonacci spiral.
Oh. Interesting.
It was fun. I know, y'all think I'm drunk.
Nerd.
All right. So if we're good with this, let's see how we do with this.
Oh my god.
Woo! So now, instead of giving you the pattern, I want you to come up with the equation from words.
They already can't English.
You already can't English. That's a problem. Somebody needs to fix the one so you can English. You look like Albert Einstein without the freaky stick-up hair right now. I don't even know where to go with that.
It looks like a completely different person.
Not in the middle of my notes, please.
Dang.
All right. So we want to find the next term of the sequence A. So I'm trying to find sequence A, so we're at A sub N. That's this part of it. The next term of the sequence A.
Okay.
Then it says is equal to. Well, that equals. Let me do this in colors. It'll be more.
Three
So,
times.
A sub N equals. Then it says 3 times. So 3 times.
The previous term, so 8
And minus
1
one.
minus.
The previous term. So A sub N minus 1.
Got it.
They want me to go backwards by 1. The previous term, that's 1
Can I
more.
flip those?
You're
Like A sub.
N minus 1 times 3? Absolutely. It's the same thing.
the end. The pattern U is previous term.
Oh,
Let's
oh, oh,
find
oh.
all over 4.
Okay? You want to move over to 3 then, since that's what you were reading instead of 2?
I mean, we can start off slow.
It don't matter. The pattern U. So U sub N is, so equals the previous term, so that's U sub N minus 1. If you put A, I would not mark it wrong. I am notorious for using A instead of the letters they tell me. So if you wrote that as A sub N minus 1, I would not mark it wrong.
Oh. Did I do this right?
But you do.
Okay.
Yeah, because it says
Plus 9. And they said all of that over 4. So all over 4 means divided by 4.
Oh. Miss Smith, I think I did 2 right.
You think you did 2 right?
Do they still do both folks from Wendy's?
Oh, 4? Yeah, my husband loves it.
Right, give me one of them days.
Yes, Peter.
With the spicy nuggets, boy.
Oh, yes. The spicy nuggets are
The
back.
Popeye's chicken sandwich is back, y'all. It's not
Yo,
even-
my friend drove to Wattsville
This time.
before opening and still didn't get one.
This time, the pattern B. So now we're at B sub N. Is equals this
B.
N minus 2. So B sub N minus 2. And I need to multiply that against the number that's 1 space back. So B sub N minus 1. So basically, what you're doing is to find this number, I need to go here and multiply that against here.
The next value.
The next one got me messed up.
Right, the next value. What you mean the next value?
The next value, the next term. All of this means A sub N.
Yeah, that's what I put.
The next term of the sequence, the next value, the pattern. It all means A sub N, B sub N, U sub N. Equals.
5 less than double. So times 2 minus 5.
Okay, times 2 minus 5, double the previous term. So 2 times your previous term minus 5, or 5 less.
Oh, ho, ho, ho.
Oh, 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 oh.
Merry Christmas.
That's seriously what it sounded like. Is this going to be on the
Dust.
test? Yes. Oh
Yo, I got
my God.
This is about to be eeks. Shout out to y'all.
Listen, what? That means I love you in German.
It's like something else, but all right.
It really does.
Okay, we are almost done. This is it. This is our last page.
Mine.
Okay. So,
You're almost done.
yes, we're almost done.
What about it?
Your homework is in your packet. The next page. That's your homework. It's in your packet. Oh, oh God.
All of
Say
them.
Jesus
Oh,
Christ.
it is.
I love when he says that. I can't. It makes my heart warm. And it makes me giggle.
Arithmetic, man. Arithmetic.
Okay.
Everything else is over. Except for what Jesus said, bro.
So, I need to figure out what my equation is telling me to do.
It's telling you to -3
Okay? So -3,
to the one previous.
use the one previous and subtract 3. So, right now it's telling me that a sub 1 is 25.
Yep.
My pattern's telling me, take that number
-3.
and subtract 3. So a sub 2 then is going to be
Subtract 3,
22.
22.
It's like 21. It's 22.
So a sub 3 then is
19.
19
And 16, 13, 10.
and
4,
16. All we want is the next 3 terms.
No,
So we can stop at a sub 4.
no, we get all.
So you need to figure out, what do I need to do according to my pattern, and then find the pattern. Find me the next 3 terms. Okay? You can also substitute in. Okay? What I mean by that, if you look at number 2, my pattern is 4 times the previous term. So 4 times the previous. So that means a sub 1, I'm sorry, u sub 1, my bad.
Yeah.
I do that all the time. U sub 1 is 3. So to get u sub 2, I take 4 times 3. 12. To get u sub 3, I take 4 times 12. 48. To get u sub 4, I take 4 times 48.
192.
Thank you. 192. Okay. So I don't care how you give me the next 3 terms, but you need to be able to decipher what is the pattern, what are we doing?
The next one we tell me.
Okay? So in number 3, this is 4. What's happening here? Times.
Four
So
times,
this is
and then
4
plus
times
one.
the previous,
And then
And
plus
you're adding 1.
and then you're adding 1. So a sub 1 is 5. So a sub 2 is 4 times 5 plus 1.
This is the most complicated one right here, I'll tell you what.
So that's
I'll
21.
tell you what.
A sub 3 is 4 times 21 plus 1. Look how bad my board is off already. 84, 85. Whoa.
Whoa, wait a minute, hold on.
What, with the 85?
No, I'm on 5.
You have to just be careful. You can rearrange that so it's different. Are you talking about because the 7's out front? And then, yeah. I'll show you here in a second. So this is 85. And then this is 4 times 85 plus 1. And you said that was what? 349.
341.
340. Oh my God. 341. I quit with this one. Okay. 4 is pretty easy too. My pattern says 3 times the previous minus 11. So B sub 1 was 6. So to get B sub 2, we take 3 times 6 minus 11. And you get 7.
Yep, it's easy.
B sub 3. 3 times 7 minus 11 is 10. B sub 4 is 3 times 10 minus 11, which is 19. Take a minute and digest it. Okay. Some of y'all are gonna fly through this, and other ones, this is gonna blow your mind so bad that you don't even know what to do with yourself. Slow and steady wins the race, my friends. Slow and steady wins the race. I don't know, for some reason, it's always the R sub n minus 1, A sub n minus 1 that just blows everyone's mind. And they can't figure out for the life of them why we use it or what it's for.
Yeah, it's extra, but like.
Well, and I think the problem is we start in math 1 with that next equals now. So then everybody's used to the next equals now, and then when I do this, it's like, whoa.
It's like 5.
The beautiful thing is, this recursive sequence is wonderful. It's pretty easy. But what if I stop you and I say, find A sub 217?
I'm just like, no, you do.
Who's gonna sit there and do this 217 times to find that number? So, exactly. We are going to learn a formula that you're actually given on your test. You get a formula sheet with this on it that will cheat for you.
Wait, like on the test or like your?
Like on your final exam.
You get a
You get a formula sheet with these 4 formulas on it, and that's
They
it.
should have been doing that.
That's all you get though. That's all you get. It's geometric and arithmetic sequence and series. That's it.
So it ain't all this time.
As much as I would love to give you all of that, all the state says that you need is this.
Why they test us on the rest of it?
Because-
Why they test us?
All right, so a lot of people get stuck with this next one because it multiplies after it subtracts. So I can rewrite this as -2 R sub n minus 1 plus 7 if I want.
That's what I'm saying.
Right? All I did was take that -2 and push it forward, and take that +7 and push it behind. A lot of kids have an easier time doing this way. I'm okay with that. So then, if R1 is -1, R2 is -2 times -1 plus 7. So -2 times -1 is 2 plus 7 is 9.
All right, I got it, but I did it the other way. I just plugged it.
If you plug it into your calculator does order of operations for you. The problem is I get a lot of kids that go 7 minus 2 is 5 times -1 is -5. They want to do that subtraction first instead of following order of operations.
You always did multiplication first.
But people don't pay attention and they just roll with it.
Sally now.
Yes, you can't forget Aunt Sally. She's a wonderful
I
person.
don't care about her.
So -2 times 9 plus 7 is -11. And -2 times -11 plus 7 is 29.
It's that one, ain't it another one?
What?
Like the thing,
Please excuse my hearing.
I know that one, but it's another one too, I forgot how.
PEMDAS?
Yeah, that.
They just call it PEMDAS.
That's
Miss
awesome.
Smith, I'm already doing it again.
Are you already doing it again? Oh. There you go, my friend. Hungry.
So big time you too.
I'm being a good kid and eating pumpkin seeds. And I did not buy any soda today. Okay. But I still have leftover skittles, so let go.
You gotta go down.
Watch me.
We're gonna throw them in the trash can today.
Why I already know?
All right. Which one of you took my pass just to play with me?
Oh, sorry, I forgot. No, I was see. No, listen. I was one.
I didn't even let him go to the bathroom. My
No,
pass is
yeah.
just missing.
No, I was gonna actually go to the bathroom. but
So
then I
you
forgot.
snatched the pass?
Yeah, no.
All right.
When I went out there, I was gonna go get her and ask her to go to the bathroom, but then I
This is it. Okay, so you need to be able to recognize two special types of sequences. The other ones, all you need to do is find a pattern. Okay, so those ones where I had to go back and take the a sub n minus 2 and add it to the a sub n minus 1, that's fabulous. It's not that important. Okay, these are the ones that they're going to focus on. Okay, the first special sequence is called an arithmetic sequence.
Are those decimals?
Okay, yes, and guess what? There's fractions too.
Oh, God.
Woo!
It's like arithmetic. Oh, my God. No, arithmetic. That's arithmetic.
Okay, so Alicia's already started. That says arithmetic, not arithmetic. I said the same thing. Okay, don't ask me why they pronounce it arithmetic, but they do. Okay, so when you think arithmetic, this is old school when like your great-great-grandparents were doing math. They called it arithmetic. And arithmetic back in the olden days was adding and subtracting. Okay, so an arithmetic sequence is patterns of addition or subtraction, but your keyword is a constant value.
So like the same number, 5, 5, 5.
So it has to be the same number. If I start adding 5, I have to continuously add 5 the whole way through. I can't switch it up. Okay? They call this value a common difference. So you're going to need to be able to write the recursive rule or write the equation with the common difference. So your recursive rule for anything that's arithmetic is a sub n minus 1, and it's going to be plus or minus d. D is your common difference. What am I adding or subtracting every time? So, mostly adding and subtracting are pretty easy to find. If you struggle with it, the way you find that D value, D equals 42 minus 25.
17.
And that gives me 17. Okay, so all I did was take this value and subtracted what came before it. So my equation is a sub n minus 1 plus 17. So that tells me I'm adding 17 every time. Oh, yes. It says homework, does it not?
Oh,
I didn't.
Read, Peter. Okay, so example 2, to get my D value, 11.1 minus 13.7. That gives me what? Negative 2.6. Okay, so a sub n minus 1 minus 2.6. My pattern's going down, so this time I'm subtracting. That's why you got a negative number.
Wouldn't that be 8?
Okay, so again, to find my D value here, 9.05 minus 5.67, and you get 3.38. So a sub n minus 1 plus 3.3. The last type of sequence is geometric. These are patterns of multiplication. Okay.
Division.
Yes, and division. However, you should really write it as multiplication. So what I mean by that is if my pattern is to divide by 2, that's the same thing as multiplying by 1/2. If my pattern is divide by 3, it's the same thing as multiplying by 1/3. So they truly want you to write it as multiplication with a fraction.
I mean, I get it.
Can you, but like this 1/2, can you put
0.5. If it's 3/4, 0.75. I'm okay with that. What? I don't care what those little girls are doing. Okay, because we multiply by a fraction, they now call this the common ratio. So my D value has become an R value. So my recursive rule is always R times A sub n minus 1. Whatever my common ratio is, times the previous term.
Okay, I wrote it like that. I just wrote it backwards.
A sub n minus 1 times R,
You're right.
same thing.
I did it wrong.
Okay, just like there was an easy way to find your D value, I can find R by taking 15 divided by 3. And that gives me 5. So my equation is 5 times A sub n minus 1. That's going to help you out when you get to problems like 2 and 3 here. Because it's really easy to see that you multiply by 5 in example 1. But when I get to example 2, that's not an easy number to multiply by. So again, I find R by taking 56 and dividing by 32. What's 56 divided by 32? 1.75 times A sub n minus 1. 1 3/4. 7/4. All the same
Ain't
thing.
there a way you can put like a fraction in the calculator or a decimal in the calculator?
You read that too?
Fraction?
Yes.
How do you?
If you do 1.75, go to math and choose choice number 1 and hit enter. R equals 36 divided by 72 this time. You should get 0.5 or 1/2 times A sub n minus 1. We just looked at a lot today. Are the brains hurting yet?
No.
Yes.
Nope. That's why I haven't said nothing this whole time.
Is your brain's hurting or it's not hurting?
Because I'm not thinking. It's,
Oh, your brain's just dead?
yeah.
I killed it. All right. On the next page, you'll see recursive sequence homework assignment. In the first part, 1 through 9, you need to tell me, is it arithmetic, is it geometric, or is it neither? I will give you a hint. There are 4 geometric. There are 2 arithmetic, which means that there are 3 neither.
What does neither mean?
It's not a continuous adding or subtracting, or it's not a continuous multiplying. It's like a mixture of the 2. Okay? If you have geometric or arithmetic, I need the recursive rule and the next 2 terms.
So we're not doing all that.
So, just like we did here, where I gave you the A sub n minus 1 plus 17. That's your recursive rule, and then give me the next 2 terms that would come in my sequence. If it's neither, all I need you to do is tell me the pattern. For example, is it plus 7 minus 2, plus 7 minus 2? What's happening? And then find me the next 2 terms. Okay? You can't write a recursive rule for something that is not arithmetic or geometric. So just tell me the pattern and find me the next 2 terms. Okay. 10 through 15. 10 through 15 are like this. Use the sequence to find the next 3 terms. And 16 through 19 are like this. Write me the equation that goes with the words. Okay. I realize that y'all are not used to so much homework. However, we need to be able to practice this because the only way we're going to get better at this is to practice. Okay. So try your best. I'm not expecting perfection.
Oh, it's not perfect in slides.
Huh?
It's not perfect in slides.
It's not going to be perfect.
Nowhere near.
Nowhere near.
It's probably not even gonna be good.
Product is multiply, right?
Yes.
Wait, come here.
Product is multiply. Quotient is divide.
Wait, come here.
Not product.